Very good morning. Myself, Dr. Ruchi Gupta. Today we will discuss the concept of unparalleled computing. Already I have discussed the concept of cloud computing in the previous lectures. So, what is distributed computing? Because cloud computing use this concept of distributed computing. Distributed, we can say that cloud computing is an enhanced version of this distributed computing. It contain all the features and functionality. Distributed computing, it is a computing model in which the multiple computers, we can say that a number of nodes are to be connected together over the network to solve a problem or to perform a task. Means in a distributed computing, all the computers are to be connected in a distributed manner, and they all are equally share their resources and processing. So each computer in a system, they have to share the processing power, memory, storage, and they have to communicate with each other to achieve a common goal. It's like we can say that it's a dividing the whole task or big task into a smaller task so that all the systems can work parallelly to compute and to execute that task. So it is like dividing a big task into a smaller parts and assigning them to a different computers that works in a parallel, and then combining the result and get back to the machine. So, key features of this distributed computing, there is a need of multiple nodes. So, it involves a connection of some independent computers. Then resource sharing, nodes share the resources such as CPU, storage and data. It is scalable, means new computers, anytime you can add or delete the computers in a network. Fault tolerance means if one node is fail, then there is no impact on the network, because it was one of the major problem with the centralized system, that if your one main system become fail, then the whole network will be shut down. So to resolve this issue, a concept of distributed computing is arises, in which if one node is fail for any of the instance, then others can continue the task, and there is no, it will not shut down the whole network. Next is the transparency to the end users. The system appearance as a single unit. As a system appearance, it looks like a single unit, but internally the whole work is to be divided into the number of nodes, even though it is a distribute. Examples of some distributed computing, internet search engines like Google uses the thousands of servers to process search queries. Even we don't know, even we are not aware about that, we have to just put the query over the Google, and it will search in a second. How it is search in a second? Because in the background there are number of parallel servers work there to execute my query. So it is one of the example of this search engine is one of the example of distributed computing. Second is the online multiplier games, like distributed tasks like matchmaking, graphics, chatting. These are the examples of distributed computing. Blockchain networking like Bitcoin, Ethereum, and they use the distributed nodes to share their transactions. Then scientific research projects, they also use the concept of this distributed computing, like SET at the rate home or the protein folding simulations. So these are some examples of distributed computing. What is the architecture of this distributed computing? So we can see here, this is the architecture of this distributed computing. Here the number of nodes are to be connected in a network. So they have to share their process and memory. All the devices are equally responsible, and they have to share their memory and resources to compute or execute the task parallelly. So we have to say here, these are the number of servers. All the machines are to be connected through the wireless LAN or the wired LAN, and the whole task is to be distributed among these nodes. anytime you can add or delete the node from the network, and it will not affect the whole network. The task or the work has been computed by the nodes. So, this is basically we have to use this concept in a distributed network, that each and every device, each and every network is to be connected together, and they have to perform, they have to share their memory, they have to share their resources, processing etc., and they have to divide the whole task into a number of small units, and then they have to compute or execute the queries. So, what are the advantages of using this distributed computing? Number one, it is enhanced performance, it enhances the network performance, because if we have to compare it with the centralized system, where the whole main server is responsible to manage the network. But in the case of this distributed computing, each and every node is equally responsible to manage the network resources. So, that's why it will enhance the performance of the network, because all are parallelly execute their tasks. So, distributed computing help to improve the performance by having each computer in a cluster, and they have handled different parts of tasks simultaneously. Second is the scalability. As we have already discussed that you can scale up your network anytime. You can add or delete any resources anytime. So, distributed computing clusters are scalable by adding new hardware when there is a needed. You can delete any resource as you are not required for that resource further. So, you can scale up, or we can say it provides us the facility of elasticity. Additionally, they can keep running over if one or more system malfunctions, thus offering scalability and fault tolerance. Now, the next is main advantage of this distributed computing is the resilience and redundancy. So, multiple computers can provide the same service if one machine, for example, if one machine is not available at the moment, or if one machine is failed due to any of the reason, then it will not affect the whole network. So, if two machines that perform the same service in a different data centers, then one data centers goes down, the organization can still operate with some other data center, because all the nodes are to be executed the same type of services. So, these are the major advantages of distributed computing. Cost effectiveness, it is one of the advantage of distributed computing. So, distributed computing use the low cost of the shelf hardware. These systems aim to achieve the high performance by reducing the latency, improving response time, and maximize the throughput to meet the shared objective. Next is the efficiency. So, unlike the traditional approach or traditional system that run on a single system, distributed applications, this is the concept of flexibility, that multiple systems run simultaneously. Efficiency, complex requests can be broken down into the number of subtasks, and they have to distribute among the different system. So, the request is simplified and work as from the parallel computing. Transparency is one of the major advantage of this distributed computing. So, distributed computing system, they can present the resources such as file, database, services if they have exist into a single computer or the location. So, they can spread across the multiple nodes. So, these are some major disadvantages of the distributed computing. Now, there are some disadvantages are also there in a distributed computing. So, the first disadvantage, the first challenge we can say that we have to face in a distributed computing is a configuration issue. This is one of the drawback of, we can say issue in a distributed computing, because if in a distributed system, if we have to add the nodes anytime, then same type of configuration it and to be able to interact with the another, it is one of the major challenge in the network. So this can bring a challenge for the organization that have complicated IT infrastructures or IT staffs have to be needed to manage the network. Second is the communication overhead. It can increase the overhead of the network, because once we have to coordinate and communicate between the different multiple nodes in a distributed computing system, so they can create some additional communication overhead. Potentially they have reduced the system performance. So this is one of disadvantage of this distributed computing. Next is the security management. Managing the security in a distributed computing may be a complex task, as the user should control or replicated data across the various locations. So it is very difficult to manage the data security over the network. Additionally, to ensuring the consistent performance and uptime across the distributed networking, it is also a challenging task. So there are certain advantages and certain disadvantages over the network in a distributed computing. Cost is one of the issue. While distributed system can be very cost effective in a long run, but this can become an issue for the organization. Complexity is one of the major problem with the distributed computing, because as we have to add more and more computers or the resources into the system, then it could be a more complex to design. So these are some disadvantages of the distributed computing. Now, the second type of computing which we have to use is the parallel computing. So, what is the parallel computing? Parallel computing, it is a type of computing where we have to divide the large problem into a different sub problems, and these sub problems are solved simultaneously in a parallel mode using the multiple processes within a single computer system or across the multiple systems. It basically, the parallel computing focus that how the task is to be divided into the number of tasks and how the task is to be executed at the same time to speed up the execution. This is the basically this is the concept of this parallel computing. So if we have to compare this parallel computing with the serial computing, as previously the work has done through the concept of this serial computing, where one problem and one processor is there. It is a very time consuming process. So now the concept introduced, the parallel computing concept is introduced. In this, the whole problem, the whole task is to be divided into the number of subtasks, task 1, task 2, task 3. Then processor 1 will execute the task 1, processor 2 will execute the task 2, then processor 3 and n number of processor will execute the n number of tasks parallelly. And they have to speed up the work, they have to speed up the execution, and the result will be given very in a efficient manner. So these are the parallel systems, like there are number of processors will work together parallelly. Number of processors will execute the task, and they have to share the common resources, they have to share the memory, and they have to perform the task. So these are the processes, they have to share the same memory, and they execute the task parallelly. This is the concept of parallel system as we have seen here. So key features of parallel computing, we need a number of multiple processors. Coarse processors are needed in a parallel computing. We have to use 2 or more than 2 processors simultaneously, they can execute the task parallelly. Share the goals, all processors work on the part of the same problem, means we can say the same problem is to be divided into the subtask, and all the processors will work on the same task parallelly. High speed, it increases the performance by executing the task in the parallel. As we know that if the task is to be divided into n number of subtasks and all the subtasks are to be assigned to a particular processor, then they are very efficiently execute the task. So, speed may be improved. Inter-processors communications means processors may share or exchange their messages because they have to share their resources, they have to share their memory in a parallel computing. Synchronization means coordination is required to processor because they don't interact or interface with each other. So, these are the key features of parallel computing. Now, the examples where we have to use the concept of this parallel computing, like weather forecasting, we are using the concept of parallel computing where huge calculations done in a parallel mode. Supercomputers use the concept of parallel computing where we have to use calculate the scientific simulation, AI, deep learning. They are using parallel computing. Medical imaging, MRI scan, data processing, for their purpose for in the medical field we are using the concept of parallel computing. Gaming and graphics like GPU performance, parallel tasks, we are using here parallel computing. In big data analytics, because there huge amount of data is to be managed by the parallel computing, Hadoop, Spark use parallel processing. So, these are some specific examples which we have to use in a specific field. Now, what are the advantages of this parallel computing? It is a faster execution of large complex problem because why it is a faster execution? Because we have divided the whole problem into the sub problems and each sub problem is to be executed by a single processor. That is why it is much faster than the centralized system. It can handle the data intensive tasks like AI simulation. It make efficient use of multi-core processors. This is one of the major advantage of parallel computing. Second, what are the disadvantages? Disadvantages are also there. So, complex programming and synchronization here. It is a synchronization between the processors. It is one of the major issue or challenge which is faced, which is which happen in the parallel computing. High cost of hardware, because in the parallel computing we are using a very high configure processors in the parallel computing. This is one of the major disadvantage of this parallel computing. Diminishing returns, after a point adding more processor doesn't help much. So, these are various disadvantages also in the parallel computing. So, if we have to create a difference between the parallel computing and high performance computing on the basis of the various parameters, like in terms of definition, goal, focus, processing unit, data distribution, scalability, communication, application focus and examples. So, parallel computing, because high performance computing, it is just an advancement version of the parallel computing. So, we can see here what is the difference between this parallel computing and high performance computing. The parallel computing, it is a simultaneously execution of multiple tasks as we have already discussed here. But in the high performance computing, it achieving high computing performance. These are the basic definition of parallel and high performance computing. If we are talking about the goal, so parallel computing improves the speed and efficiency because it divides the whole task into the subtasks and they all are work together parallelly. But if we are talking about this high performance computing, they optimize performance and scalability also. If we are talking about the focus, the task decomposition, it focus on to divide the whole task into the number of subtasks. Here the high performance computing, it optimizes in system architecture. If we are talking about the processing units, so multiple processors or computers work together. Here, multiple processor, GPU and specialized hardware work together. Then we are talking about the data distribution. Divide the whole task across or the data across the multiple resources. Here they efficiently data movement and memory management. Communication, it use the IPC facility, inter-process communication, and it will use the high bandwidth intercommunication with movement. Then scalability, scalability means scaling, adding, we can add more processor anytime. Here by scaling, optimizing the algorithm and architecture. Application focus, it is used to solve the complex problems, and here it is a computational intensive task or the data set. Examples where we have to use the parallel computing, we are using the parallel computing in weather forecasting or the molecular dynamics, and the high performance. Here we have to use this for genome sequencing, climate modeling and simulation. So, we have to see here that how, first of all, what is the concept of distributed computing, then what is the concept of parallel computing, and how it is differ from the high performance computing. So, this is all about the concept of distributed and parallel computing and high performance computing. So, thank you very much.